Well done for scanning this code to have a look at how we generate electricity. The first thing we need to know is that we're going to use a magnet to generate electricity, and surrounding a magnet is a magnetic field. I'm going to change the strength of the magnetic field at various points here. Second thing you need a coil of wire, which is a wire looped around on itself and connected up to the appliance that you want. The blue dots on the inside is the charges within the wire. We might sometimes refer to these as the electrons, but I'm just going to keep to using the word charges now. Now, to generate electricity, we need to take our magnet and a magnetic field surrounding it and move it through that coil of wire. And the magnetic field forces the charges around. It gives them a certain amount of voltage, which is a bit of energy to each lump of charge. And that energy, you can see, as the moving current, the speed at which the electrons are flowing. Now, how do you increase the amount of electricity we generate? Well, first of all, we're going to increase the strength of the magnet. As you can see there, we've increased that. And secondly, we can maybe move it faster. Do it more frequently. And third one, let's increase the amount of loops that the magnet goes through. And if we increase more loops, then we've got more of them electrons to actually force around. Now, moving it back and forwards isn't very useful, so what we're now going to do is rather than move it in and out, we will rotate it. Same thing's happening. We're still moving that magnetic field around and forcing the wires, the charge in the wires to move, so giving it some current. And as you'll also notice, when it moves backwards and forwards, the charges go backwards and forwards. So this is a type of current called alternating current, which is what your laptop charger would be running on, or the mains would be running on initially.